Okay, so we talked about the unit circle last lesson, and how to find the trig functions from the unit circle. So how do you find sine, how do you find cosine, and how do you find tangent using the unit circle? Okay, quick reminder, to find sine, you use the y value of the ordered pair of the point on the unit circle. To find cosine, you use the x value, and then to find tangent, you use y over x. Okay. Now we're going to look at graphs of sine and cosine. So to graph sine and cosine, we're going to use the unit circle. Okay, and we're going to use kind of the x value for cosine. We're going to use the y value for sine. Okay, but those are going to be the outputs. So what are the inputs for the parent functions of sine and cosine? The inputs, or the x values, are going to be the radians, or the degree measure. Okay, we're going to graph it in radians. You could also do it in degrees. But we're going to stick with radians. Okay, and then the outputs for sine, so we're going to graph y equals sine of x and y equals cosine of x. And again, those x values don't represent the x values of the unit circle, they represent the x values in terms of the inputs, the radian degrees, or the radian measures. The output of sine is going to be the y value on the unit circle. Okay, so if, for example, if we were trying to find sine of pi over 6, okay, sine of pi over 6 is the input. That's the x value, and the output is the y value. So sine of pi over 6 is 1/2. Okay, so we're going to be graphing the point pi over 6 comma 1/2. Okay, so input versus output. Input being the radians, output in sine's case is the y value of that unit circle. Okay, let's get rid of that. All right, so the outputs again are the y values. Okay. Well, there's a ton of points on the unit circle. Okay, we're not going to graph all these points. We're just going to graph the main ones. Okay, but the unit circle, remember, it goes all the way around 2 pi times. Okay, and then it just repeats itself over and over again. So we're only going to graph up to 2 pi. Okay, and we start at 0 radians and at 2 pi. Okay. All right, and then what output should we, or what input should we pick? Well, we know we're going to have 0 and we're going to have 2 pi. Halfway between 0 and 2 pi is pi. Do a better half. Okay. Halfway between 0 and pi is pi over 2. So we can graph that. Oops. And then halfway between pi and 2 pi is 3 pi over 2. Alright, so what are all these? These are all the quadrantal angles. Okay, so it's in degrees it would be 0, 90, 180, 270, and then 360. Okay, but in radians it's 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, so those are our x values. Let's get our y values. Okay, at 0 radians, the output, that y value, is 0. Okay, so 0, 0. Okay. All right, at pi over 2, what's the y value? At pi over 2, which is right here, the y value is 1. So we're going to have the point pi over 2, and then up 1. So we're going to have to label the y-axis here. And then, we might as well label the negative 1/2, minus 1. All right, what's next? We got pi is next. What's the y value at pi? Okay, here's pi. The y value is 0 again. Okay, so we're going to graph pi, comma 0. At 3 pi over 2, 3 pi over 2, the y value is negative 1. Okay. And then last spot is at 2 pi. Okay, well 2 pi is the same as 0. 0 radians and 2 pi are the same, and that's 0 again. Okay, so it's back to where we started. Okay. And then that'll keep going as you go around and around the unit circle. That keeps going, but it's going to follow this pattern. It's going to stay the same shape Whoops. So this shape is a sinusoidal curve, it's called. So for sine, it goes up and back down. It's like a wave, up and down, up and down, up and down, over and over again, because again, the circle just keeps going and going and going. All right, so that's the graph of sine. All your sine graphs are going to be based off that parent function. What's the graph of cosine? Okay. Well, for cosine, we're going to have the same. We're going to graph the same inputs. Okay, so we're going to do 0. We're going to do 2 pi. Okay. And then we'll cut those in half. Okay. And we're going to label the y-axis the same. 1 and down to -1. All right, and then this time our outputs for this are going to be the x values of the ordered pairs. Okay. So for all of these, we're going to go through the same thing. We're going to grab all the quadrantal angles and get the x values this time. So starting at 0, the x value is 1. So that's the point 0, 1. Okay, so 0 on the x-axis, 1 on the y-axis. Pi over 2. Pi over 2, the x value is 0. Okay, so pi over 2, comma 0. That's the ordered pair. Now again, these graphs don't look like the normal graphs because they're only sections of it, but you do have all 4 quadrants here. Okay. Pi is here. X value is -1. So pi, comma, -1. 3 pi over 2. Down here. Y values, all right, 0, so back to 0. And then 2 pi, what's the y value? Again, it's the same as 0. It's the same as where we started, which was up at 1. And that is the graph of sine. Okay. Now it's the same shape, it's still that wave, but the difference is the starting point, which we're going to note in a second. But it's that same wave. Now again, this one would also just keep going and going. So all these graphs just keep going up and down and up and down. They keep going in the same pattern because that circle keeps repeating. Okay. All right, so now we're going to note the starting point of each graph. Sine starts at, well, in the parent function it starts at 0, but it's not always going to start at 0. So what we say is it starts between the high and the low points. Okay, so it starts halfway between the max and the min, we'll say. Now starting point's kind of relative because, you know, these graphs go on forever in this shape. But when x equals 0 is kind of what we're going to say for right now as the starting point. All right, well, cosine starts, in this graph, starts at the max. Cosine's always going to start either at the min or the max. So it's always going to start at the high point or the low point, whereas sine starts halfway between the high point and the low point. Okay. So those are the 2 graphs we're going to be looking at for the next couple lessons. Again, these graphs are called sinusoidal. It just means that wave shape, that pattern is just going to keep going over and over again, repeating itself. Okay, so there's 4 special parts of the graph that we're going to have to be able to identify. The period, the amplitude, the midline, and the frequency. We're not going to deal with frequency too much, but we'll define it. So the first one is the period. Okay. The period is the distance, the horizontal distance, it takes for the graph to repeat itself. So it's the distance horizontally between any 2 sets of repeating points. So how long until that wave pattern repeats itself? Okay. Well, on the parent functions, we only graphed 1 period. Okay. So we graphed it until it repeated itself again. So the period on these parent function graphs was just between 0 and 2 pi, which is a horizontal distance of 2 pi. Okay, 2 pi minus 0. Okay, so the parent function's period is 2 pi. Okay, it's not always going to be 2 pi, but that's kind of reference point, the starting point we're going to have. The amplitude. Okay. The amplitude is halfway between, it's half the distance, this time the vertical distance, between the high point and the low point. Okay. Or between the min or the max. It's half the height. So between the min and the max, half of that is going to be your amplitude. The formula, if you want to use the formula, is the max minus the min divided by 2. But when you have a graph, most of the time you can just count it out. So there's the min, there's the max. It's between -1 and 1 for both sine and cosine. So halfway between -1 and 1, okay, that's a distance of 2. Half of that would be 1. Okay. So the parent function amplitude is 1. Okay. So again, between -1 and +1, that's a distance of 2 units. Half of that is 1. Okay. Similarly, the midline. Let's wait for this to load. Okay. The midline is the max plus the min divided by 2. So it is half the distance between. It's similar, but it's the place that is halfway between. It's a vertical shift from the x-axis. Okay. So how far above or how far below is the middle of your graph? Okay. Well, on both of these graphs, the midline is the x-axis. It's halfway between the high and the low. It would be 1 plus -1, which is 0, divided by 2. So the midline for the parent functions is 0, sometimes written y equals 0 since it is a horizontal line. Alright, and lastly is the frequency. We're not going to do the frequency too much, but the frequency is the number of cycles the function completes in a 1-unit interval. Okay, and the interval we usually use is 2 pi. So how many times does the graph repeat itself? How many full cycles or partial cycles does it make in one interval, in the interval of 2 pi? The frequency is the reciprocal of the period. So if you know the period, you automatically know the frequency. If you know the frequency, you automatically know the period. Okay, so the inverse of the period would just mean it's 1 divided by the period. And again, we're not going to find that because it is so closely related. But in our parent functions, it's 1. It makes 1 full cycle. All right, for these examples, we're going to find the type, the amplitude, the period, and the midline. Type meaning cosine or sine. All right, so I always identify important parts on the graph first. First thing you notice is that it starts at the maximum, which automatically makes it a cosine graph. The amplitude, so I'm going to label the min, and the max. Min is 0, the max is 2. The amplitude is going to be max minus min. And I go ahead and draw the midline in there as well. The middle part, and then I note where does it repeat itself. So it starts at a max. Where does it get back to the maximum? Okay. So like I said, amplitude min minus max, or max minus min, 2 minus 0 divided by 2. It has an amplitude of 1. The period, again, starts at a max, gets back to the max in a span of 4 pi. And then the midline, 2 plus 0 divided by 2 is 1. It's also that dotted line I drew, y equals 1. Okay. Second one starts between the min and the max, which makes it a cosine graph. It repeats itself. When does it get back to the origin? So this is a sine graph. The amplitude is how far above the midline is it. It goes 2 above and 2 below. Okay, or the formula would be 2 minus -2 divided by 2. The period, like I said, makes 1 full cycle between 0 and pi. So the period is just pi on this one. And the midline is the x-axis, y equals 0. That's the middle of the graph. It's between the high and the low. All right, and this last one starts at a minimum, okay, which makes it cosine. We'll mark where it gets back to the minimum. It gets back to the minimum after pi, which makes at the period. The midline, it is shifted down 1 unit, so the midline is -1. Y equals -1. And then the amplitude, the high and the low, you can just count it out. From the midline, you could go 3 below and 3 above, which makes the amplitude 3. But you could also use the formula for that. Or again, when you have the graph, you could just count it out. So it is between, you go up 3 from the midline, down 3 from the midline. It means your amplitude is 3. All right, so that is the 4 things you're going to have to be able to identify from a graph. Again, there are formulas. You don't have to use them. A lot of these you could visually see. But you should be able to identify what type of trig function it is, the amplitude, the period, and the midline.